Good afternoon, good morning, or good night. Right now, we're going to go into exponents and radicals. Okay, it's an important thing to know for the SAT. And here we got all different kinds of questions from analyzing word problems to just solving exponential equations or using the properties of exponents and radicals to solve any equation. Okay, so let's go into number one. We got an equation here. So since this is a exponential equation, we know that 60 is the initial value. We know that the 3 means it's triples, it's tripling, so it triples or a 200% increase. Because remember, we got 1 plus the percentage inside the parenthesis. And t over 2 means it's happening twice as slow as it would because the exponent is being divided by 2. So let's read this. The number of microscopic organisms in a petri dish grows exponentially with time. The function p above models the number of organisms after growing for t days in the petri dish. Based on the functions, which of the following statements is true? Okay, so the predicted number of organisms in the dish triples every 2 days. The predicted number of organisms in the dish doubles every 3 days. The predicted number of organisms in the dish triples every day. And the predicted number of organisms in the dish doubles every day. So we know it's not doubling, so we know it's tripling, or is a 200% increase. So we know that this is wrong, and this is wrong because it says doubles. So now the point is, what do we have to look for? Is it tripling every 2 days or every day? So if t is the number of days, we know that this exponent right here has got to be 1 for it to triple because 60 times 3 to the first power equals 180, right? So that's going to be tripling. So it's going to triple every 2 days because t has to be 2 for the exponent to be 1. Let's check it here on the table. Okay, so x, y, we know that when x is 0, y is 60. In other words, when t is 0, y is 60. You can always go to y equals, and put the equation there, 60 times 3 to the power of x over 2. We can go second table and we can analyze the table. When x is 0, y is 60, we know that. When x is 1, y is 103.92. So we can see it's not tripling every day. So this is wrong. When x is 2, it's 180. When x is 3, it's 311, 312 more or less. When x is 4, y is 540. So it triples from here to here, then triples from here to here, and it's going to go on like this. That's the property of an exponential equation. Okay, let's look at number 2. The function above, let me turn that off. The function above can be used to estimate the number of farms, f of n in millions in the US, for n is between 0 and 72. And I know that this is the initial value. We know that this is a 2% decrease over time. Okay, which of the following is the best interpretation of the number 5.77 in this context? We know it's the initial value, so I always advise everyone to, before even reading the question, analyze the equation. Know which one is the initial value. It's a percent. If it's a percent decrease or percent increase, and analyze the exponent as well, just like we did on the first question. So we know that 5.77 is the initial value. So it's the estimated number of farms in millions in 1940. Yes, because n is the number of years after 1940. So 1940 is when n equals 0. So it's right. The estimated number of farms n years after 1940. No, this is the whole equation. This is 5.77 times 0.98 to the n power. The estimated decrease in the number of farms in millions each year after 1940, no, that's 0.98. And the estimated percent by each the number of farms decreased from each year to the next after 1940, no, the estimated percent is a 2% decrease. Okay, let's do number 3. Which of the following expressions is equivalent to negative 4x cubed to the 2 over 3 power. So we know if we have an exponent to another exponent, we can always distribute the exponents by multiplying them. So we're going to multiply this by this and this by 1 because it's not written here. So you know this is going to be equal to negative 4 to the power of 2/3 times x cubed to the power of 2/3. All right. So let's solve for x cubed here. So we know that this is equal to x. 3 times 2 is 6 divided by 3 because we're just multiplying. And this is the same thing as negative 4 to the 2/3. Okay, so this would be x squared, right? Because 6 divided by 3 is 2. Let me see if there's anything we can already cancel here. So we can cancel out a and b because a and b have x cubed instead of x squared. So let's see here what we got. So negative 4, 2 divided to the 2 over 3 power. Okay, so to solve this, we gotta turn this into a radical. So how do we turn this into radicals? I don't know if you guys remember it. We did that on the intensive. So the denominator comes to the square, to the root. So this is going to become a 3 and negative 4 squared. Okay. So what can we do now? We can just do negative 4 squared, which is 16 cubed to the cube root of 16, sorry. So to the x squared power. So now we can simplify this. So we know that we're going to find perfect cubes in order to solve for this. I know that 8 is a perfect cube. So I know that 16 is 8 times 2. So 8 times 2 is 16. And I have the properties of radicals here on my side that I can rewrite it like this. So 8 times 2 is equal to 16. So the cube root of 8 times the cube root of 2 is equal to the cube root of 16 times x squared. The cube root of 8, that's why I try to find a perfect cube, is 2, because 2 times 2 times 2 is 8 times cube root of 2 times x squared. So as you can see, C is the only right one because D didn't have the most simplified answer. In case you don't know how to do this, you can always look up to this point. So we have the cube root of 16 times x squared. And here we have 2x squared times the cube root of 16. So where did this 2 come from? We don't know. So we would assume C was right. And this could be rewritten as 2x squared times the cube root of 2. Okay. So even if you didn't know how to simplify the cube root of 16, you could have figured out that D could not be right because this 2 just appeared out of nowhere. Okay. Which of the following, number 4, which of the following is equivalent to the expression above for all x is greater than 0, where a and b are positive integers? So if I look at the answer choices, they're pretty much just turning radicals into exponents. We can just do what we know. The a comes to the denominator. So that becomes x to b over a, c. Okay, let's do number 5. We've got a graph here. Remember what we talked about graphs? Knowing how to analyze graphs in the title and the axis is very important. So this graph is telling us the future value of an investment after 20 years for different interest rates. What are they? Compound daily and compounded annually. Okay. So this is the annual interest rate. The circles are the compounded daily. The squares are compounded annually. And we got the future value as the y-axis. So as we can see, as x increases, in other words, as the annual interest rate increases, the future value of both increase exponentially. But we know that the compounded daily is going to increase faster, right, as x increases than the compounding annually. So let's read this. An initial investment of 1,000 is made at a constant annual interest rate. The graphs above show the corresponding future value V in dollars of the investment for different annual interest rates are after 20 years. We know that. One graph shows the value when the interest is compounded daily, and the other graph shows the value when the interest is compounded annually. We already knew that as well. Which of the following statements is true? As R increases at a constant rate, what is R? That's the annual interest rate. V increases more rapidly if interest is compounded annually than daily. That's not right. Especially when it's daily, as you can see on the graph. As R increases at a constant rate, V increases more rapidly if interest is compounded daily rather than annually. Okay, that makes sense. So let's see. As R increases at a constant rate, the difference in interest compounded daily, interest compounded annually increases at a constant rate. Now we don't know that because it's exponential. If R equals 15% and the interest is compounded annually, so 15% is right here. A $1,000 investment will be worth 20,000 after 20 years. So let's see it. Compounded annually, so it's right here. No, it's worth around 15,000. Compounded daily would be 20,000. So we know that B is right. Always checking the answers to see if one makes more sense than the other, but shouldn't be the case in the SAT, okay? Let's go number 6. Radioactive substances decay over time. The mass M in grams of a particular radioactive substance D days after the beginning of an experiment is shown in the table below. So we got the number of days, which is X, the mass Y, we know it's decaying because the mass is decreasing as the number of days increases. If this relationship is modeled by the function m of d equals a times 10 to the bd power, which of the following could be the values of a and b? All right. What does the a represent? The initial value when d is 0. So that's 120. Okay. So m of d, we know that at least is 120 times 10 to the bd. So we know that b and a are wrong. Okay, so we got to know what the value of b is. We can pick any point. Okay, let's pick this one right here. Okay, so if we can do two different ways, we can just solve for the value of b, but since b is a exponent, it's going to be harder to solve that in the calculator. So I'll advise you to just plug in the value of b to see if it makes sense. So we know that when d is 30, the mass is 103.21. So let's check for the both values of b. So let's do it. So if b is 0.0022, we'll see if the mass is 103.21 when d is 0. Okay, so let's see 120. So let's check not b, let's check option C. So 120 times 10 to the power of b, which we're assuming is 0.0022 times 30 because 30 is d. So if that's equal 103.21, we know C is right. So let's check it. So 120 times 10 to the power of 0.0022 times 30. 139. Nope. So C is wrong. We go with D, but let's check it just in case. Okay. So 120 times 10 to the negative 0.0022 times 30. So let me go up here, copy this, go in here, second insert, so I can insert the negative sign. There it is, 103.21, close enough to 103.08. So D is right. Okay. So that's equal to 103.21. Okay. The equation above can be used to model the population in thousands of a certain city t years after 2000. So we know that this is the initial value. In other words, that's the population in 2000. Okay, this means it's a 0.5% increase when t equals 3, because 3 divided by 3 is 1. We talked about this before. According to the model, the population is predicted to increase 0.5%. Okay, so that's the 1.005 here every n months. Okay, so t is years. Okay, so what is the value of n? Okay, so what's the value of n, which is n months? We know it's going to increase 0.5% every 3 years. Why? Because when t is 3, then the exponent is 1, and then the 0.5% increase is going to take place. Okay, so 3 years is the same thing as 36 months. So D is right. If 2 is square root of 2x equals a, what is 2x in terms of a? So we got to solve for 2x in terms of a. We can divide everything by 2. So this cancels out. Square root of 2x equals a over 2. Now we can take the square root of both sides. I mean the square of both sides, sorry, not the square root. Okay. So 2x equals, now we got to use the properties of exponents. We distribute this to the a and this to the 2 as well. So that's a squared divided by 4. So 2x is equal to this, a squared divided by 4. So divided by 4, that's b. Easy money. Let's keep going. Which of the following expressions is equivalent to 16x to the 9th y cubed to the 1/2 power, where x is greater than 0 and y is greater than 0. Okay. So as I can see here, every single question is in exponential form. So I know every single answer is in exponential form. So I know I don't have to worry about changing this to radicals or anything in that regard. So let's distribute this to here, this to here, and this to the 16. We cannot forget about that. So this would be 16 to the 1/2, x to the 9 halves, because 9 times 1/2 is 9 halves, and y to the 3 halves. So as we can see, D is wrong because this should be divided by 2. This is wrong because this should be 9 divided by 2 and 3 divided by 2. This could be right, and this is wrong because 9 divided by 2 is not 3. So this should be 9 divided by 2. This is wrong. So B is the only possible answer. As we know, 1/2 is the same thing as the square root of 16, right? So that's why letter B is wrong, is right. So 3 over 2, so that's equal to 4, x to the 9 over 2, y to the 3 over 2. They could have written this in radical form, which would be equal to 4 square root of x to the 9th power, y square root of y cubed. Okay, because remember how the denominators becomes the root. Okay, so we could have combined this as well. So 4, because the roots are the same, and this is a property of radicals. If the roots are the same, we can combine the numbers into a single root. So this would be x to the 9th y cubed. So those were possible answers as well if the test wanted to. Okay. Okay, 10, we're almost done. Just 2 more, maybe 3 more. If square root of x to the 5th power divided by the cube root of x to the 4th power equals x to the a over b. For all possible values of x, what is the value of a divided by b? Okay, so first of all, I want to transform this into exponents. So I know that the rule that I'm going to use is same base exponents, we subtract the exponents. So This is equal to x to the 5 over 2 divided by x to the 4 over 3. Remember how the roots always becomes the denominator in the exponent. So now we know that this is equal to x, 5 over 2, minus 4 over 3. So we gotta make the bases the same. The common base between 2 and 3 is 6. So x, 6 minus 6, that's the same base. So we multiplied 2 by 3 to become 6. So we gotta multiply 5 by 3 to become 15. So the ratios are the same. We multiplied 3 by 2 to become 6. So we're gonna multiply 4 by 2 to become 8. Okay. So that's equal to 15 minus 8 is 7. So that's x to the 7 over 6. What is the value of a divided by b? That's just 7 over 6. Okay. You can use this in the calculator as well. So you can go to, you can just do 15. Oops. You can just do 15 divided by 6. No, not 15 divided by 6, because we already matched the denominator. So let's do 5 divided by 2. Minus 4 divided by 3. And that's going to give us a decimal. We can go to math. 1, that's going to give us a fraction from the answer. So that's 7 over 6, just like we found it here. But you got to know how to manipulate fractions and do addition, subtraction, multiplication, etc. for the test anyways. That's why I'm just telling you how to use the calculator, because you can save time after you know how to do that. Okay. For all values of x is the given expression equivalent to 70n to the power of 30x, where n is greater than 1. Okay. So first of all, let's turn this um, into exponents, because this is in an exponent form, exponential form. So we know that this is equal to 70n to the power of 1/5, assuming like this is a single term. And if this is a single term as well, we can do that this is 70n to the power of 1 over 6, right? To the power of 2. Okay. So 70n to the 1/5 times, and this is a single term, not only the n is to the 1/5 power. Okay. So 70n 2 times 1/6 is the same thing as 2 over 6, okay, because we can distribute this 2 right here. So that's equal to 70, parenthesis, n to the 1/5 times 70n to the 1/3 power. Now that we have the same basis, 70n and 70n, we can add the exponents. So that's equal to 70n to the 1/5 times 1/3 plus, sorry, not times, plus 1/3. Okay, so now the base is going to be the same. So let's do here 1/5 plus 1/3. The common denominator between 5 and 3 is 15. We had to multiply 5 by 3, so 1 has to be multiplied by 3 as well. We had to multiply 3 by 5, so this is going to be a 5 up here, because the 1's going to be multiplied by 5. So that's equal to 8 divided by 15. So that's 70n to the 8 divided by 15. Okay, so 8 divided by 15 equals 30x. Simple. So 8 divided by 15 equals 30x. We're going to find the value of x. Okay, so we can multiply both sides by 15. So 30 times 15 equals 450, 450x. And now we can divide both sides by 450. So 450 divided by 450. So x equals 8 divided by 450. 0.018. Or this 8 divided by 450. So let me turn that into fraction. That's 4 divided by 225. I don't know if this fits the SAT answer, but if not, 0.018 should be good enough. Okay. Let's go to the last one. Which of the following is equivalent to a plus b over 2 squared? So this is different from multiplication, right? Because up here, for example, we can distribute it because everything is being multiplied. But here, everything is being added, so we got to do the distribution. A plus b over 2 times a plus b over 2. So we do a times a, that's a squared. A times b over 2, that's plus ab over 2. B over 2 times a plus ab over 2. And b over 2 times b over 2, that's b to the fourth, b squared, sorry, b squared over 4. Because 2 times 3 is 4. So that's equal to a squared plus 2ab over 2, because we got 2ab's over 2, plus b squared over 4. So we know that this is b squared over 2. That's wrong. This is wrong because it has no middle terms. So D is the only possible answer. Why? Because we pretty much just simplified this. A squared plus ab plus b squared over 4. Okay. Hope you like this. This should be a pretty good homework for exponents and radicals. We covered word problems. We covered some key points of turning exponents into radicals, radicals into exponents. We covered some graphs, some tables, some straightforward problems. And yeah, so that I think that was pretty good. Just remember, always look at the questions, always look at the answers. See if what the answer is telling you. If the answer wants the question in if the answer wants the answer, of course, the work to be in exponential form, don't bother thinking about radicals. And if the answer is in radical form, just like I gave you the example here of what could have been, then you know what to do based on how the answer choices are laid out. Okay? Have a good one. I'll see you in the next video. Bye bye.